All right, let's take a look at example number 1 here, and we're asked to determine the measure of an angle, okay, angle WXZ. Now, WXZ is going to be the 3 points that make up this angle. So we start with W, we go from W to X to Z, so we are trying to find what is this angle right here, okay? And I'm just going to shade that in purple right now. We're trying to find that angle right there. Now, technically, this would be one of the angles in the triangle WXZ. Okay, this would be this angle right here. And the thing is, it's not a right angle triangle. You will notice that there is no right angle here or there or there. So this is not a right angle triangle, so we have to do things a little bit differently. Okay? And how we're going to do that is to find a couple of different angles. Now, we do have some right angle triangles. We have triangle ZYX, okay, ZYX, that's a right angle triangle. And we also have triangle WYX, so that's this little triangle right here. And so what we can do is we can find this large angle, okay, so we can find that large angle, and then we can find this small one, and we're going to subtract them from each other. So we're going to find, now again, this is using terminology here, angle YXZ minus angle YXW. Okay, that's what we're going to be doing. We're going to find this big angle, subtracting the small one, and that's going to equal angle WXZ. Okay, if you need a moment just to pause the video and to take a look at where each angle is coming from, glad to go ahead and do that. Remember that an angle is made up of the 3 points that kind of use those 2 lines. Okay, so 3 points that make up those 2 lines. Now, let's, first of all, we're going to find angle YXZ. Okay, YXZ is the big one, so we're going to find this big angle. And for this big angle, this is going to be our adjacent side. This is going to be, this whole thing here is going to be our opposite side, okay? Because we're doing the big triangle here, find the big angle. Now, adjacent and opposite, that's going to be tan. So tan of theta is equal to opposite over adjacent. And if you want to adjust it right away, our theta is equal to tan -1 opposite over adjacent. We can switch it up like that right away. Now, our angle, so we're going to say angle YXZ is equal to tan -1. Remember, theta and our angle, it's just 2 different ways of describing it, and we want to make sure we know which angle we're talking about. Our opposite side is these 2 added together. So this was 4 meters, that's 3 meters. We have a total of 7 meters over our adjacent, which is also 7 meters. And angle YXZ is going to equal, now if you want to, you can use a calculator. Maybe you have already figured out what it might be. If we do inverse tan, we get 45 degrees, exactly. Now we're going to use the exact same formula for the other one. So to find angle, we're now doing YXW, okay, and just underline there. Angle YXW is equal to tan -1, but now this is the opposite, and this is still the adjacent. So it's going to be 4 meters over 7 meters. YXW, so 4 divided by 7, second function tan, is 29.74 degrees. So that's how we find both of those. Okay, so we find both those angles, and then we need to subtract. Okay, so that's when we subtract. So YXZ is 45 degrees, YXW is 29.74 degrees, and when we subtract these, 45 minus our answer is 15.26 degrees. And that's going to equal angle WXZ. Okay, so that's our missing angle. So the small one right there is 15.26 degrees. We find both of them and then subtract. Okay, and that's how we solve for that missing angle.